we've looked at what exponents are, right? Just like 5 to the 3. We've looked at what an exponent of 0 does. We've looked at what negative exponents do. So today we're looking at rational exponents. You know what a rational exponent, what it means by that? It means like a fraction. So what happens if you have a fraction in the exponent? It's something different. And it's complicated a little bit because when you have a negative exponent, it often turns what you have into a fraction. But this is what if the fraction is in the exponent. Okay, it does something totally different, as I hope you might expect. So here we go. What does it do? We're going to talk about radical form and then exponent form. Okay, and we're going to compare the two because you may not know the term radical, but when you see it, you will know what it means. So I'm going to do square root of 9. And when I write, actually, I'll leave that for after. So what does that mean? What does the square root mean, Sarah? Yeah, well, it's asking what number to the 2. So this is asking what number to the 2 gives me equals 9. And as Sarah said, it's 3. So if I was evaluating this, the square root of 9 is 3. The nice thing about it is you can do that on your calculator. Okay? So how do I write this as, oh, actually, let me try another one. What about this? What does this mean? Have you ever seen this before? Okay, so if you haven't, the whole time you've been writing square roots, we don't show it, but there is actually a 2 in there. Because you could also have a cube root, or third root, or fourth root, or fifth root. And what does that mean? It means what number to the 3 gives you 8. It's 2. So the answer to this one is 2. So that might be a new notation if you haven't seen that before. And we could put any number, and it kind of goes in the little like V, right, of the root. Okay, so we do a lot of square roots because they come up more often in grade 9 and grade 10. They come up a lot, Pythagorean theorem and among other things. But turns out you could take any root. So how do we write this in rational form is what we're doing today. This would be the square root of 9 would be written as 9 to the exponent 1/2. So my exponent has a numerator and a denominator. And if I'm just doing the square root, the denominator would be a 2 because this was a 2. And so this still equals 3. It means the same thing. Whoa, zoom out. Okay, still be 3. So how would I write this one? Ellie? Very good. 1/3. So the denominator of the fraction, the number in the bottom of the fraction that's in the exponent, see how this is like different from a negative exponent, which makes the base into a fraction, right? And it gets complicated when you have to do all of them all at the same time. So this 3 is the same as that 3. They go together. Does that make sense? And again, like I said, you could also do the fourth root of something. So the fourth root of 16 means what number to the 4 gives you 16? And it's 2 again. Okay, and that would be 16 to the 1/4. Okay, so any questions about that? Straightforward. That's just definitional. It's new, but I hope that it's straightforward. It's just learning a new notation, a new way of writing things. Your calculator will have a button, if you have a good calculator in particular, I'll show you what it looks like on mine in a moment once that boots up. So we're going to write this in general. N, the nth root of A is the same as A to the 1 over N. And this can go both directions, of course. Everybody okay with this so far? What if I had something like this? Let's see, what do I want to do here? Square root of 4 all cubed. How would I write that? Because I can write it all as one exponent, and I would write 4. This is like 4 to the 1/2 all cubed. But when you're doing a power of a power, you multiply. So it's the same as 4 to the 3 over 2. So when I'm raising it to an exponent like 3, like if it was 5 to the 3 or 6 to the 3 or 7 to the 3, that's the thing that we've seen lots of times, right? We know what that means. That number goes in the numerator. And when I'm taking a root, that number goes in the denominator. What do you think? Is everybody? Yep. We're gonna want to write it all 3 ways, quite frankly. We want to write it like this because it's the most simple way of writing it, and that's kind of what we're going to work towards over today and tomorrow. We're going to do this over a couple of days. But this is useful to know that that's what it means, and this is another way that we write it sometimes. Or you might see a question like this and you have to turn it into that or something. So we want to be able to go back and forth between all of them. Okay, so again, in general, if I have the nth root of A and raise all of that to the m, that's like A to the m over n. And on my calculator, I've got this button that takes a square root. So again, I would do square root of 9, and that would give me 3. But see if I hit shift. So it's going to be different on yours. If I hit shift, I get the third root of something. So shift third root of 8. We did that one. That's going to give me 2. And then if I wanted to do anything else, I've got this one. So I would go shift, hit that, fourth. Every calculator is going to be a little bit different, but that's how I would do it on mine. But you would have some buttons, so I can help you find it after when we get started on some of these examples. You can do these on your calculator, absolutely. You don't need to be able to do these in your head, but you need to understand what they mean and be able to type it in and that kind of thing. All right, let's try a few examples here. We're not evaluating these. These would give you nasty decimal answers, a lot of them. Woo. You just got it back, now you're going to break it. Oh, no. So we're just writing these in the other form. This is exponential form because it's giving it to me with an exponent, and I'm going to write it in radical form. That's the other one. But like I said, I think all of these pretty much would work out to decimals, which is fine. Sometimes you have a decimal answer, absolutely. But we don't have to evaluate these. So what does 5 to the 1/3 mean?
Is it 3 and then the square root sign of 5?
Yeah, exactly. And we call it the third root of 5, but you do the square root sign or the root sign or the radical sign is what we call that. We put a 3 in to show that we're taking the third root, and then the base goes inside the sign. So somebody else, what would 615 to the 1/9 be? Yeah, so, and we would call it the 9th root of 615. I'm going to do that one and just see what I get. Shift 9th root of 615, 2.04115043, and it probably repeats. We don't care about those numbers. We're just getting used to this notation. What about this one? Ellie?
25 to 3, like, cube, square, cube root.
Yeah, good. Cube root. Okay, so let me write that. So I'm going to take the cube root of 25 like that.
And then brackets around.
Again, so very good. So this top number is going to make it bigger, and this bottom number is going to make it smaller. Oh, what about this one?
Would it be cube root 25 and then all in brackets -2?
Yeah, you could do it that way. Actually, there's a lot of different ways. I like that. So I'm just going to do that like this. So cube root of 25 and all of that to the -2. And what does the -2 do? We got to know this for our quiz tomorrow.
Applies to all of them.
Yeah? And so,
Makes it.
what do negative exponents do in general? Anybody else? Zach, what do you think?
Gives you the reciprocal.
Yeah, you flip it. So this would end up being 1 over the cube root of 25. And you don't need the brackets. We do sometimes just write the 2 on the sign like that, as long as it's clear that it's an exponent. You're definitely going to get away with that. The other thing I could have done is I could have flipped it in the first place. This is 1 over 25 to the positive 2/3, right? Just because it's a fraction doesn't mean the negative exponent changes anything. Negative exponents still flip your fraction, give you the reciprocal, which is a great word. Okay, and then I would write the 25 to the 2/3 in radical form, and that would, and it, would work out the same. Ask questions if there are any, otherwise we're going to keep going. Oh, that was it for that. So now these ones, it's giving it to us in radical form, and we're writing it in exponent form. So, and we need rational exponents for this. Again, these ones wouldn't evaluate, like the square root of 37 is going to be some decimal. Write each of the following in rational exponent form. Who thinks they have an idea of what it might be? I won't call on you. Put your hand up if you think you probably know what it is. Okay, who is willing to share? Sarah, sure. Is that what other people thought? 37 to the 1/2? Is that what you guys thought? Good. So the square root is the same as raising it to exponent 1/2. It's 1 over that root. So what would the next one be?
61 to the exponent 1/5.
Very good. Question?
No.
Oh, are you going to answer this one? Go for it.
101 to exponent 5 over 3.
Nice. 111 to the 5 goes on top. That's okay. And the 3 goes on bottom. Everybody good with this? Okay. And now it says evaluate, leave answers as fractions where possible. So preferably no decimal answers. It doesn't say that you have to like write it in the other form first, but we're going to kind of do that as we go so that we always remember what's happening. Now, this first one's not a rational exponent, not a fraction exponent. So this is where we get to do a little bit of review for the quiz tomorrow. So what is 5 to the negative 2? Ben, what do you think? 5 to the negative 2. What do negative exponents do? Jada, what do you think? Yeah, nice. 1 over 5 squared, which is 1 over 25, right? So we're supposed to actually evaluate and leave it as a fraction. Okay, next one. So how would I do B? Pearson, what do you think? Nice. So so our example A is what happens if it's a whole number. It's 5, so 5 over 1 becomes 1 over 5. 2 over 3 becomes 3 over 2 to the positive 3. And what happens to an exponent that's on a fraction? Sir? Yeah, so the exponent applies to both. And then I got to figure out both separately. So 3 to the 3 is 3 times 3 times 3, 27. And 2 to the 3, 2 times 2 times 2, 8. 27 over 8. How many people have a calculator that gives them answers in fractions? Anybody? No? Really? Oh, wow. That's too bad. So you could type, because you could type 2 over 3 in brackets to the negative 3. You could type that into your calculator. But if it doesn't give you the fraction answer, that's useless, and you're going to have to show steps. On the quiz and on the test, I want you to do this. Down the road, you may eventually just have to evaluate, and you wouldn't have to show steps, so you're going to get away with it. But right now, we're learning what negative exponents do. So you can't just use your calculator, because then that doesn't show any learning, right? Negative 5 all to the 0 is going to be, who remembers these? Look at question C and look at question D. We've done these like, 3, 4, 5 times now, and we often actually do it exactly with 5. So this one, you're saying this is 1, and D would be? Jess, what do you think? Forget which one's which, but you know one's 1 and one's the other? Yeah, and D is negative 1. So you got to remember, inside the brackets, the negative counts with the 0, so it's gone. Outside the brackets, it doesn't count, so it's still there. Because the 0, like kind of, an exponent of 0 kind of eliminates everything. Doesn't matter what's in there. I could do a picture of a flower. It's a pretty good flower, isn't it? I could do a picture of a flower to the 0, and it would give me 1. Like the exponent 0 turns everything into a 1, including negative signs, including fractions, including variables, apparently including pictures of things. But if the negative is not in the brackets, the 0 doesn't apply to it. Okay, continuing on, where are we? Example E. This is an easy one. That's like a grade 9 question. What's the square root of 25? I think we kind of already saw it. 5, how'd you get that? Just know that one? And what does it mean? It means it's like the opposite of 5 squared is 25, so the square root of 25 is 5, right? You all know this. It's too easy. So this is like, and the way I could have written this is 25 to the 1/2, but you don't have to. The instructions didn't say you had to. We're just evaluating here. And again, it's like 5 squared is, 25, right? That's what it's means, the opposite of that. 16 to the 1/2. You don't have to rewrite this in radical form. What would the answer be? Square root of 16, which is 4. Very good. So the answer is 4. but what it meant was the square root of 16, right? With a 2 there, you don't have to write the 2. When there's no number written, it means square root. But if you're doing any other number, you got to put that number in there.
So we're supposed to write it as the square root. That's it, or-
For this, it just said evaluate. So the answer is 4. You don't have to rewrite it in radical form. But on the test, like there will be questions that say rewrite in radical form. Do not evaluate probably, or maybe you will, maybe you won't, I don't know. You know what I mean? And then, but eventually, really the whole point of this is that we know how to evaluate these things. 32 to the 1/5. What does this mean? The 5th root of 32, or what number to the 5 gives me 32? Does anybody know what it is? It's 2. If you don't know that, that's where you're going to have to learn how to use your calculator to calculate these. So like Ellie asked, you may have to show that step. You may not. If you don't, you just write equals 2 and you got it. We want to know the rules, but we also want to know how to evaluate them. And using your calculator is fine for that. Negative 32 to the 1/5. So this is not a negative exponent. So it's not flipping it. This is where people start to get themselves confused because there's all these different rules happening at the same time, right? This is just like negative 32 to the 1/5. And we just did 32 to the 1/5. So it's like negative 2. You don't need the brackets, and you don't need to show steps, but just reminding us that that's what it is. I'm going to show you something quickly. It's not going to come up in our lesson today, but if it comes up in the homework, or we'll talk about it a bit more tomorrow, I think. If I try to take the square root, so the square root of 16, we just did that one, it's 4. What about the square root of negative 16? Does anybody remember what happens for this? Error! Remember, you can't take square roots of negative numbers, because square root is what number times itself gives you the thing you're talking about. So nothing times itself can give you a negative, because you're either going to have no negatives. If it's 4 times 4, that's positive 16. Or it'll be negative 4 times negative 4, which is still positive 16. You're going to have 2 negatives. Does that make sense? You can't take the square root of a negative number, but watch this. What's the cube root of negative 8? You can have negatives with cube roots. We'll talk more about that later, but that's something that you can wonder why. Who can help me understand what's happening for question I? What do you think?
It's just 36 takes 1 1/2.
Nice. 0.5 is the same as 1/2, which is the square root of 36. And what's the square root of 36? Pearson, did you just do it? Oh, I thought I saw you. 6. Some people know a lot of square roots, just they kind of have them in their head because they just remember them, and some people don't, so that's fine. Like I said, you can use your calculator. 125 to the 1/3. So again, this is the third root of 125. What's that going to give you? I wonder if this calculator on the computer has this. Nope. Doesn't look like it. Who's got this one?
5.
5. 5 times 5 times 5. What number times itself 3 times gives me the number inside the sign there? That's what it's saying. Good. A few more. So this is one where you may want to rewrite it so that you can remind yourself exactly what it's saying. And we're going to do the 2 and the 3 kind of as separate steps. So how would I rewrite this? So remember, the denominator to the 3 goes in there. and then the 2 goes outside the brackets. So what's the third root of 8? We've done this one a bunch of times.
2.
It's 2. So this is 2 squared, and 2 squared is 4. Easy enough? Same thing. Why don't you try L yourself? So where's the 3 go? Where's the 2 go? The 3's on top, the 2's on the bottom. So I'm going to have this. And the 2 goes in there, and the 3 goes out here. 3's on top, it's making it bigger. 2's inside the sign, it's on the bottom, it's making it smaller. Square root of 25 is 5. I think we know that one. And 5 cubed, we've kind of done this, is 125. Now mixing negatives and radicals. What does the negative do? Nanette, what does the negative do? Flips it. Very good. So I would just do that 1 over 16 to the 1/2. Right? So the negative is gone, and then everything stays on the learning goal. Some people did that step correctly, but the next step, they just wrote the 16 part. Whoops, forgot that it's 1 over. So be careful. It stays 1 over for the whole rest of the question. And this is, like the square root of 16. You don't need the 2, but it's there. Square root of 16 is 4, so 1 over 4. Questions? We've got a couple more here to do. Try this one yourself. All right, looks good. People are on the right track here. So this one is 1 over 25 to the positive 3 over 2, which is 1 over square root. So that's the 2 of 25 all cubed. And we just did that up here, didn't we? See, it's the same question as L, 25 to the positive 3 over 2, 25 to the negative 3 over 2. And look what it does. So this is 5 cubed, which is 1 over 125. So for L, we got 125. All we did for this one is change the exponent to a negative. We got 1 over 125. Didn't change the 125 part. That's so important about negative exponents. And what do you think for this last one, O? So we gotta and I see people doing these in slightly different orders, which is totally fine. Whatever you like is good. You'll notice that I always get rid of the negative sign first as a first step. That's just my habit. And I would say, if that it's a good way to do it, but if you're doing it a different way and you like it, then by all means continue. Don't flip the fraction in the exponent. You're flipping the base. 2 over 3 does not become 3 over 2. It's the base that flipped, right? And then what do I do? The 3 tells me I'm taking the cube root of 27 squared and the cube root of 64 squared, right? So again, the exponent applies to both the top number and the bottom number in the fraction. Cube root of 27 is 9. Cube root of 64 is 4. 9 squared is 81. 4 squared is 16. Any questions?